Hello, this is Mr. Gilmore with the 13.3 Parallel and Perpendicular Lines. Today we investigate the slopes of parallel and perpendicular lines, and we're going to find the equations that we will get after we produce the results of whether the lines are parallel and or if they are perpendicular. Let's dive into first the results of today's lesson. We're going to arrive to two key results, one for the parallel lines and one for the perpendicular lines. The two results are here. The first result is that parallel lines will have equal slopes. The second is that the slopes of perpendicular lines are opposite reciprocals. So we're going to begin our investigations into the parallel slopes, and then we'll turn our focus toward the perpendicular, and then we will conclude our lesson by looking at some examples with both. So parallel slopes, if we envision two lines, M and N, and call them parallel, what we find then when we place these lines on our coordinate plane is that the slopes of each of these two lines will be equal. They are equal in the same value. So the slope of M and the slope of N are in fact the same slope. And so we'll find these to be parallel. So when you hear the word parallel, you think same slope. That's how we're going to actually use that to help us find the equations of some lines that are in fact parallel. Now, there's a couple of assumptions we've made then. The first assumption is that the lines that we were given did have slope, essentially meaning that we assume them to be non-vertical. But what do we say then about two vertical lines? Well, we'll go ahead and then also assume that yes, vertical lines are in fact parallel. So the results we have then for our parallel conclusion is this, that all vertical lines are going to be parallel, and any non-vertical line, if we find them to be parallel, will have the same slope or equal slopes. For our perpendicular lines, we use this phrase called opposite reciprocal. To determine an opposite reciprocal of any given value, let's assume that we've got a ratio of two quantities, A over B. To find then the opposite reciprocal of A over B, we simply negate the fraction to make it the opposite value of what it is, which means if it was positive, we make it negative. If it's negative, we make it positive. And then we make it the reciprocal, which is then altering where the location of our numerator and denominator values are. We move the numerator and the denominator to the opposite location. So numerator goes to the denominator and the denominator moves to the numerator. So our example here of A over B turns into negative B over A is what we have an opposite reciprocal of. For the perpendicular slopes, then, what we say is the slope of a perpendicular in the opposite is the opposite reciprocal of the slope of the original. So in symbols, if we find that the slope of our line, of a given line, let's say is A over B, then the slope of the perpendicular to that line would be negative B over A, because we take the opposite reciprocal of that given fraction to then end up with our conclusion to that perpendicular line. So let's then talk about doing several examples of determining what the parallel slope would be to a line, and also what the perpendicular slope will be to a line. And we'll follow up with this lesson with just several examples to follow here. So we're given a line that passes through the points -3, 9, and 5, -15. What we want to do is find its slope, which will essentially be then the same slope of any parallel, but we also want to find the slope of the perpendicular, which means we're going to apply that opposite reciprocal value to our discovered slope. So the very first thing we want to do is find out what is the slope of this given line. Well, we do y sub 1 minus y sub 2 over x sub 1 minus x sub 2 minus x sub 1. So we have x sub 1, y sub 1, x sub 2, y sub 2. Let's then find the equation, or find the slope of this line. So we're going to do y sub 2, negative 15, minus y sub 1, which is 9, over x sub 2, which is which is 5, minus x sub 1, which is negative 3. So the numerator, negative 15 minus 9 is negative 24. The denominator, negative 5 plus 3, right, because we do subtract a negative as adding, is then positive 8. We then get our slope to be negative 3. Negative 24 divided by 8 is negative 3. Now, what that means for us is, I'm going to use some subscripts here, that if I were to find the parallel slope, I'll do little parallel symbols here. Let me actually make those a little more parallel. Parallel symbol here, the slope parallel then to this line would be negative 3. But what if we wanted then the perpendicular slope? So the perpendicular slope, let's do m subscript perpendicular, that's the symbol for perpendicular, remember, is then the opposite reciprocal of negative 3. So how do we find the opposite reciprocal of negative 3? We imagine negative 3 is over 1, so we flip it, and then we make it the opposite of what it is. So negative is going to become positive, and then we flip the numerator and denominator, so it becomes 1/3. So there is our answer. There's the parallel slope to our line. There's the perpendicular slope to our line, given that the line passes through these 2 points. So we can also find the equation of this line, which we'll do here in a little bit. But From knowing what the slopes of our, knowing what the slope of the line is, we can determine what parallel slope it must be, and also what perpendicular slope it must be. Let's do a second example. In the second example, we're going to be given both equations of two lines. The question asked is, are the two lines parallel, perpendicular, or neither? Well, parallel means we'll find the slopes to be the same. Perpendicular means we'll find the slopes to be then opposite reciprocals, and neither means it doesn't fit into any one of those categories. They're neither the same, nor are they opposite reciprocals. So in order for us to do this, we have to find the slope of each line. Now be careful, the slope is not just simply the value in front of the x. We must have it in one of our slope forms, or one of our forms of a line. I prefer in this case the slope-intercept form, because once it's in slope-intercept form, y equals mx plus b, then I know which value of my slope is. So let's take our first equation there, y minus 3x, and let's actually turn that into the slope-intercept form of the line. So let's add 3x to both sides. We get y equals 3x plus 7. Now it's in slope-intercept form. So from this line, we get our m value is 3. Okay, so let's hold on to that. Let's find the slope of our second line. We have this 6x minus 2y equals 4. Let's then figure out what our value of slope is. So I'm going to solve for y. I'm going to subtract 6x on both sides. I get 2y equals negative 6x plus 4. I'm going to divide by negative 2 on both sides. I get y equals 3x minus 2. And from there, I find what my slope is. There it is. My slope is 3. We'll take a look. As we compare then the slopes of our first line to our second line, we find that these two lines are equal. Check, which means we lead us to our conclusion to say that our two lines are in fact parallel, because parallel lines have equal slopes. So there we have it. But let's say they were opposite reciprocals, then we claim it to be perpendicular. Or if they didn't fit into any of those two categories, we say the two lines are just simply neither, right? Because not every set of lines we give are going to be parallel or perpendicular. In some cases, actually in most cases, the general case is that they will be neither. But we can determine that again by the given information from our two lines. And so on the homework assignment, you'll see that you'll be needing at some point in time to make sure you put these equations into point slope form, so you can, or sorry, slope intercept form, so you can find the slope and then compare those to determine whether or not they are parallel, perpendicular, or neither. Let's continue our journey on to just a couple more examples. Let's say that we're given an equation of, or sorry, let's say we're given a slope of a line is 3. What we want to then find is the point slope and the slope-intercept form of a line, let's call that line N, that is parallel to the given line M, but it passes through a specific point 4, negative 6. In other words, we want, so that we're given a line M, okay, so here's our line M, right here. But we want to find the equation of a second line, line N, that's parallel to line M, but it passes through the given point 4, negative 6. Or in other words, we have this x sub 1, y sub 1, and this is the slope that we're working with, m equals 3. So if we see the word parallel, then we know that we need equal slopes, right? So we need equal slopes. So if the given slope of our line is 3, then we know that the parallel slope must then also be 3. So with the slope given and our x and y coordinates over here, we're going to find then the point slope form of the line and then the slope intercept form of the line very quickly. So the point slope form, y minus y sub 1, which is then our y minus negative 6, equals m, which we just discovered is our 3 value, times x minus x sub 1, and there, if we clean this up a little bit with that first y minus negative 6 is really y plus 6. That is equal to 3 times x minus 4. We then end up with our, that is our point slope form. Let's turn that into our slope intercept form by simply solving for y. So we get y plus 6 equals, distribute that 3 through, 3x minus 12, and then we subtract 6 on both sides. We get y is equal to 3x minus 18, and there we have it. We have the equation of our slope-intercept form. And so with the given information, we can determine lines to be parallel to other lines through given points. And that's just like you'll see on the homework assignment as well, where I'll give you the equation of slope m, you give me then the equation for slope n, such that it is either parallel, or in fact, you'll see here in our last example, it could be that I'm asking for you to find the perpendicular line. Let's dive into our very last example, where it's set up almost the same way, except for one word has changed. We're still given line m that has a slope of 3, but this time we want to find n, line n, to be perpendicular to line m through the same point 4, negative 6. Now, our slope we started off with was m is equal to 3, but this time we don't want the parallel, we want the perpendicular slope to this value of 3, which means we're going to need to take the opposite reciprocal of 3. So imagine 3 is over 1. So we flip it, make it the opposite of what it is. It's going to become a negative. That's negative 1 over 3, right? Negative 1/3 is what we get opposite reciprocal. So there is the slope we'll be using with our x sub 1, y sub 1 of our ordered pair, and we'll plug this now into the the point slope form, and then we'll turn that into the slope intercept form as well. So y minus y sub 1, so y minus negative 6 equals our value of m, which is negative 1/3, times our x minus x sub 1. Oops, I can replace that in there, which is just 4, and then we can solve. So we can polish that up just a little bit. Y plus 6 is equal to negative 1/3 times x minus 4, and there is our point slope form. And we can then find the slope-intercept form by solving for y. So distribute that negative 1/3 on the right, and then get y by itself. So y plus 6 equals, distribute the negative 1/3 through, you get negative 1/3 x plus 4/3. Now that means when we subtract 6 on both sides, we need to turn 6 into a common denominator of 4/3. So we can turn 6, then multiply the top and bottom by 3. So we get actually then negative 18 over 9. No, that's not right. Multiply top and bottom by 3. So negative 18 over 3. There we have it. And so we have so we have positive 4/3 minus minus 18/3. So our final answer, y, is equal to negative 1/3 x minus 14/3. And so yes, you will probably have to see some adding, subtracting fractions on your homework assignment. Not too big of a deal. We can definitely tackle that. And there we have it, our slope-intercept form. So with a given slope and given point, we can actually find a parallel line through that point with being parallel to the given, which means it has the same slope, or we can find the line that is perpendicular to that point of the given line by finding the opposite reciprocal slope, and then putting that and finding the equation of the line that's perpendicular. So we see now that with our linear equations, we can actually tackle linear equations whether they are parallel and or perpendicular, given the prescribed information, whether it be 2 points, whether it be the given point and a point not on the line. We can actually determine what the relationship of the two lines are. So please be sure to hop over to the 13.3 homework assignment, take a look at those parallel and perpendicular lines. If you do have any questions on that homework assignment, please do not hesitate to email me with that. Be good and do good.